by the way, just another question.
Yeah,
Where is the share screen button?
yeah. There's a we're live now, and for sharing screen,
Okay, press it.
I can whenever you're ready, just let me know, and I can uh, I believe change it so that we can share the screen. Uh,
Okay.
but yeah, let's just start off with. We're here today with a special guest who was a TA of mine at Duke, Darren, and he's a PhD now from Duke in the you were EE, is that correct?
Yeah, yeah, computer engineering. Yep.
Computer engineering, and now you're at Microsoft Research. And yeah, you want to introduce yourself and talk a little bit about your background?
Hey everyone. I'm Darun. I'm a recent PhD from Duke. I worked on machine learning and more specifically on natural language processing. My research interests were to integrate like structure and feedback based natural language processing. Basically, the traditional components in machine learning and NLP. It's about structure and semantics of languages. So how can I incorporate that into the more modern deep learning based frameworks so that you can get the best of both worlds? So that would lead to like performance improvements, and I showed that we are able to improve on several downstream tasks, including the machine and and like search and other tasks that involve like multiple languages. And over the years, I've also done internships at Amazon, Microsoft, and Google, where I demonstrated these learnings through different industry applications as well. So yeah, I'm pretty honored to like talk about one of my research topics today, uh, with application for MLOps.
Great. So you do you want to do you want to start first? I think there's a present tab that we can switch to where we do.
Yeah,
I think this. If you select present, you
yeah,
should be able
correct.
to. There we go. Perfect.
Yeah, yeah. Able to see my
Yeah, perfect.
slides.
Yep.
Okay. So for today's presentation, I'll talk about one of my tasks that I did for a research project in my PhD, and it's called like number entity task. And I'm going to use Azure notebooks to uh, deploy and experiment with this task and improve the pipeline, then later you can deploy it on more sophisticated frameworks like Azure machine learning pipelines. So like with any other ML project, you have this MLOps development cycle. And here I'm going to just keep it simple because since I'm only using Azure Notebook, we have three stages: the exploratory data analysis, and then the feature engineering and model experimentation. Before I talk about these individual sections with the code, I'd like to give an introduction about the topic itself. uh, so what is like number entity? So in order to introduce number entity, first I need to talk about what is numeracy. So language models can figure out text. So as we see, I eat an apple eats me, I eats an apple. Like in these sentences, the current state of the art models are able to figure out that the first sentence is grammatical and realistic, while the other two sentences are not, because of uh, like grammatical reasons. But with numbers, it's still not able to quite figure out what is realistic and not realistic. For instance, John's height is like 999 meters. These kind of sentences are still being generated by language models because it doesn't have the understanding that a person cannot be realistically that tall. And for instance, global warming could exceed 100 Celsius within 5 years. So what happens here is that like there is a need to inform language models about the magnitude and quantity of numbers. And in this project, basically, I classified numbers to different types and provided that information to language models in order to help it better generate numbers. So now that we have seen what is numeracy, I'll talk about what is number entity. So just see the sentence where like 1% of those at school in Southeast gained no passes in like 2010. So you have several numbers here like 1, 2.5, 2010, all that. It's obvious that the one with percentage symbols are percentages and the other one is year. While it's quite clear to humans, it may not be the case for NLP models. So there is a need to like label them into different classes and feed that information along with the task so that the models could be able to classify them. And this could extend to like other objectives. Like this task is called sequence labeling. So here you see a stream of numbers, basically 82 kg, 177 centimeter, and these are all different units. And this again comes under different types of numbers that we need to classify. Basically, in sequence labeling, you could have multiple numbers within a sentence, and the model needs to do a classification simultaneously on all those numbers. So the idea that we want for NLP models to learn is like we want embeddings of a word form of a number and its numerical form to be roughly the same. Like you don't want the model to think that the word 3 and the numerical form of 3 is different. So since numbers are often present on text, so the idea is like the embedding of numerical form of 1 plus embedding of word form of 3 should be roughly equal to embedding of numerical form of 4 and vice versa. And so there are some things that I did to improve this. But before that, I'd like to show the 3 cycles that I talked about in MLOps cycle. That's through the code, so that you can get an understanding of how I implemented the data analysis, feature engineering before I actually go for the model development. Just a second. Yeah, you're able to see my code, right?
Yeah.
Okay. So yeah, the first step is exploratory data analysis. So here it's just a standard train test split. But basically what we have here is like 5 fixed classes that you see: year, percentage, data, date, count, age, and size. In fact, 6. And we assign like unique IDs to all these classes. Uh, then it's just a standard like train test split like that we have, like 80% for train and 20% test. And here I'm kind of counting the percentage of data points under each category. So you see like there are overall 440,000 sentences, and in each sentence these are the number of percentages that belong to each category. So you see that certain types have very little data, while majority of it belongs to class 0 and 1, which is year and percentage. So this data is definitely not uniform. So which means like we could try certain strategies like data augmentation to balance data out, but I'm not going to show it in this presentation, but just an insight. So once we have that, I'll show you a sample sentence. So yeah. So this is a sample sentence. So the outfest pick of the day, July mask uh, out of Annapolis. So here, like you see that the number in the sentence has been masked, and these are the annotations for it. So it's like the actual number is 10. So we know that July 10 represents a date. So that's why you see that the sense type belongs to category 2. Here, just to confirm, category 2 is date. So this is how I kind of annotate all these sentences, like 440,000 sentences. But the good thing here is like, since we cannot annotate all the 440,000 sentences manually, so what we did was we just picked picked representative samples from each category, like around uh, 500 sentences from each category, annotated it manually and then used a model to learn that annotation and then extend it to all the 440,000 sentences. So that saved us like a lot of time and annotation efforts. So once I have that, like I'll show you the model definition. So this is like a standard BERT model. So what does a BERT model do? Like basically you feed in the input sentences and you dictate how many classes are there, and then you do a classification on each sentence to one of those classes. And here we have around uh, 400,000 sentences, and I have to show the number of classes. We have around 2,000 unique numbers. I'll show them just a bit. So yeah, the model definition goes something like this. This is a standard transformer model with like several layers that you see, 0, 1, 2, 3, all the way till n minus 1. And the what matters here is the final layer. Like here, the representations from the final layer are being fed to uh, like this classifier, which has 1870 output features. So here we have 1870 unique numbers. So which means that every sentence is going to be classified into one of those classes. That's pretty much the model definition, but I'll show you the uh, training pipeline for this talk. I've not trained the model for like a lot of epochs, just one epoch to show how it works. Sorry. So yeah, just after one epoch, we have around like 37% accuracy on the test data, but it doesn't matter. Like as we're going to keep training, it's going to increase. But uh, this is pretty much the training loop. And let's see some results to see how well it works. So yeah, so this is the inference. Like let's take this sample sentence. HP announces a laptop with up to mask hours of battery life. So here again, the task is like I'm picking a sentence and calling it, let's say, fill in the blanks. So it's FITB. So any number in a sentence is just blanked out, and the model has to make a guess of the number. And as you can see, even for humans, it's very tough to exactly predict the number because the laptop here could have 20 hours of battery life or even 40 hours of battery life. But the important thing is it probably cannot have 500 hours of battery life. So this is what we want the models to learn. We want it to learn a range or like the magnitude of number as opposed to actually predicting the exact number. And here you see these are the first top 5 predictions made by the model. Like it's 48, 24, 12, 10, 40. The model thinks these numbers are probably could be the battery life of that HP laptop. And this is the confidence scores. Like it's like it says 13% it thinks 48, and 10% it thinks 24, and overall these confident numbers are normalized and it adds up to 100. Likewise, so here like it's the important thing is even though it has not made the correct prediction, the right answer is 32. You see that the predictions are around that range, like around 30, which tells us that like our model is able to like learn that range. And likewise, for the next example, we have Rolling Stones food wine event to take place in New York City on May blank 2012. And here again, as humans, we know that since the blank is followed by May, it should be a number between like 1 to 30 or 31, like since it's a month of a day. And the model predicts all the numbers are within that range. Um, like I'll show you in the slides um, how a model fails to predict that within that range if we don't incorporate this number entity type. But since we have incorporated this number entity type to the NLP model, it's able to do that prediction within that range. So here the 33, and you see all the numbers are around 23. And like I can also show an example with the case where it predicts it right. And here it's like interview with someone for part blank, and the right answer is to part two, but our model also predicts it correctly here. Like it predicts two with a confidence of 58%. So which means that yeah, it has very high confidence when it predicts the correct number. So yeah, I'll show you how this has been done now. Uh, so yeah, so basically what we have seen is like we had an input sequence X that had like tokens or words as we call it, ranging from X1, X2 all the way till Xn, and then the output entity predictions for each token, which means like any number could be classified into percentage, date, age, count, like and those six categories that I said. So the score for of a pair consisting of an input and output sequence, like basically, uh, this is formed using like two components. The first one is a transition matrix. So what this says is like we just saw that like a date within a month is usually followed by a month as an indicator, right? Like you cannot have suddenly have number 30 thrown around. Like if you want to say May 30, the word May should be present. So that transition is actually captured in this matrix, where like any token can only be preceded or succeeded by its related tokens. That is the matrix A plus the probability of predicting that token in that position. Like given that this number is like 2, and it talks about part 2 or part 1, something like that, what is the probability that it belongs to one of the category types, which is percentage, date, age, count, etc. With these two metrics, you're going to get a score for an entire sequence that's called like SXY. And finally what we're going to do is use a function called softmax that picks the uh, sequence with the highest score among all the possible sequences. And yeah, that's I've again explained that in the first line here. And how we achieved that is using this X class, which is like the uh, sorry, which is like the different categories that I said: percentage, date, age, count. I mean, I don't have it here on the slides, but I showed it on the code. So that class type is called X class here, which is concatenated to the embedding information to NLP model, which helps the model to do well. And we saw some examples there, but I'll show you the difference, how it looks with and without that information, that number entity information that I'm talking about. So here you see that the first case, it's like Dancing with the Stars results for November 16 blank season 11 week 9. And yeah, here since it follows a typical date type, we first say the month, then the day and the year. And you see that the predictions are all years. But when I take the top 10 predictions um, of the baseline model without the number entity information, you see like a lot of double digit numbers. That tells us that the baseline model really doesn't have an understanding about the number entity types. But if you see our model, like here, for instance, iPhone blank to begin production in July, all the numbers are like, within 1 to 11. So it kind of understands that iPhone 100 is probably not launched yet, like based on seeing all the data points. And all the numbers are around the correct answer of 5. And likewise, we have some more examples where the baseline model again fails to like predict numbers around the same range, but the number entity model is able to do that by predicting everything within that range. And we also see the right answers in the top n predictions. And likewise for another example involving years. So how do we capture this numerically? So we have a metric called like dist, which basically is like the distance, pairwise distance between the correct answer and all the predictions. And ideally, if the model does well, this distance should be minimized. Since all the predictions are around that range, you should have a total distance which is much lesser than the baseline model. And that's what we see here. Uh, so in the baseline model, first we see the accuracy in prediction. We get like solid improvements in terms of accuracy, like ranging from 1% all the way to 2%, for different cases, which is top 1, top 2, top 5, and 10. So what this means is whether the correct answer is predicted within top 1, top 2, 5, or within the top 10 predictions. And likewise in distance, we see massive improvements. Like since we see here that like the number entity model is able to predict numbers within the range of correct answers, the distance for our model is much lesser than the baseline model. So yeah, this pretty much is the update I have in terms of like the this task. And in terms of development, so since we are able to get improvements on this, the next step, for someone would be like to create a Azure machine learning component where this entire code becomes a component and you can create your own environment. Since this uses like Hugging Face transformers environment, you can create that, add all the packages and make it as a dependency. And you could also have a separate data component. And once this data and code component is connected, uh, you should be ready to go. And yeah.
Wow. So the you're using you're basically are you fine tuning a pre-existing Hugging Face model?
Yeah. Here, yeah, I'm pretty much just fine tuning uh, pre-trained Hugging Face BERT model.
Ah, okay. And are you using Azure GPUs?
Yeah. In this case, it was just like basically for students, we get like a free tier. So they give like bare minimum GPU. So that's why I ran for like 1 or 2 epochs. But yeah, I think at Microsoft, you should be able to like, once you subscribe, you should be able to get like pretty good GPUs.
Yeah, there's one of the things that I'll put it into the comments here that I'm that I've been working on at Duke is a MLOps template for people to do GPU based work in the classroom. And I'll after this I'll add you to it. I think I have your GitHub handle, but basically, it's designed to work with Hugging Face as well, like where essentially you can it has Hugging Face installed, everything installed already, but you actually get extremely powerful GPUs for free in education. So I was just thinking of your example. I was like, oh, this would work pretty well with something I'm working on right now. So I would actually be interested to see how that would run actually using the templated repo, because you would take, I think, very little work to actually get that fine tuning job to work. It should essentially you just copy your script over, and as long as the data is in the local directory, it should work pretty well.
Yeah. Here we use like thousands of sentences. Like still, it's not greater than a million, but typically in like machine translation, all that we have several millions of sentences. So I think in that case, we'll see the difference, massive difference.
Yeah. So the idea here is that this is some of the stuff I'm not an expert in that you are, is that one of the problems with NLP currently is that the whenever you see a numerical representation of a number versus a word, is it that there currently are problems in creating a accurate version of it? Is that correct?
Yeah. So basically, any token in like NLP should be represented by vectors, and basically there is not very good representations for numbers.
Ah, okay.
Numbers are also tokens. Like just whenever we read a book or newspaper, we have lots of numbers. Like right now, NLP models are able to do a good job in like forming vectors for words that are like nouns, adjectives, verbs, and all that, but it's not quite good for numbers. So what
Hmm.
happens is the relationship between numbers and words are affected because of this. Like you could have like the similarity between good and great is high as opposed to good and bad, but it's not really the case for similarity between 100 and 1000 as opposed to 100 and 1. It
Uh,
thinks that all these numbers are just the same,
I
and
see.
there is a need where we kind of specify to the model that there are properties of numbers like the number line and all that that we try to teach to NLP models. That is,
Okay. So is this, and this is interesting because I know that there is a lot of effort right now around maybe math, right? Like I've heard many people talking about how they're interested in actually consuming mathematical problems so
mhm.
that when we develop GPT-3 like models, that you could actually, basically ask it a question like, give me the summation of this range, or, something like, or an equation. And so your approach actually might be one of the approaches that people that are trying to convert um, mathematical notation, right?
Yeah, yeah. So this is like I would say a starting point for that. Like, yeah, when I first started working on this, like there were very few people involved in this, but right now, yeah, there are like more sophisticated models that tackle like automatic problem solving and all that. Like
Okay.
just by reading questions, it's even able to do algebra and all that, like at higher levels.
Have you had a chance to play much with some of the OpenAI playground recently?
No, no. When I was student, I mean, I didn't have access to like the OpenAI thing. I just had a preview like from online
Yeah.
resources. But I never fine tuned or like used the playground mode.
Yeah, I'm curious. I would be curious to see, like, in the next, let's say, 5 years, and you're showing how it could be possible, is like, could we start asking a computer to solve numerical problems, or even, you know give it equations, or even interpret English into an equation. And it seems like that like the approach you're showing is the start, right, of maybe being like basically LLMs
Yeah,
being able to actually solve math.
yeah, yeah. That's true. Even in right now, like there are papers I think from OpenAI and even Google and Microsoft, like that are able to do like for instance, there is a math version of GPT called Math GPT, something like that. And they actually specifically target this problem solving domain, but I still think like there are setbacks in terms of like the accuracy. For instance, GPT has shown to like do well on to certain range, but it sometimes misses trivial things like addition, like even though it's able to do complicated things. So which means that it has actually not learned the mathematical rules for
Mhm.
numbers. So that's why this is more like a principled way of teaching models how to deal with numbers. So we are explicitly optimizing for the objective that numbers are related to each other through the number line property and not just how we read it on text.
So would it be the case then that with this kind of training, in a sense, it would be a fine tuning step, maybe, from, and that would almost always be the way that someone would use your technique, would be to fine tune.
Yeah. So again, like for the constraints in terms of resources and the data set size that we have, fine tuning is the best methodology that I adopted, since my data set also was not in terms of millions. But for models like GPT and like T5, in the pre-training stage, it might need like several millions of sentences. And once we have that many sentences with different forms of numbers, I think, yeah, we'll have a very good, and also the compute power to train those models. I think then, yeah, we'll start seeing more improvements. But right now, I think this is in an unsupervised setting. Like all the numbers that you see on the internet, no one has given any rules for it. Like, this number belongs to this type, or that number 10 could be represented as a sum of 6 and 4, for instance. It's not dictated explicitly. So that's where we still need some human intervention, like for annotations and people to do some form of labeling to
Mhm.
tell these models that these properties exist and all that. But once it's able to do a decent job in learning those properties, I think we'll start seeing tremendous results.
Yeah, and so far with Hugging Face, how long have you used Hugging Face? Is it recent or you've been using it for a while?
No, Hugging Face I've been using pretty much throughout my PhD since,
Ah,
yeah,
okay.
it's like, yeah, since everyone, right when Bird was introduced. I think it was from 2018, Bird was introduced, and then probably a year later, I think Hugging Face launched it. Yeah, that's when
Yeah,
I've started using.
yeah. I've it's been not too long for me really. I've only been using Hugging Face maybe for probably a year or something like that, and the more I use it, the more I like it. And I'm actually now teaching Hugging Face in the data engineering class, um, for the mids program, actually the
Mhm.
data science program, so that basically they're learning how to use it. And one of the problems though with Hugging Face initially was that because there's been historically not the ability to use GPUs in the university setting, it's almost impossible, right, to get a GPU. I mean, if you're a grad student and there's like a dedicated GPU, that's different. But in general, like it's been very difficult. But
Mhm.
I don't know if you knew that recently, um, we probably I hadn't told you yet, but basically now all of the students that are in my class get free GPUs, and they're actually extremely powerful GPUs that
Uh-huh.
are inside of GitHub code spaces. And so
Wow.
that's the template that all after we talk, I'll give you access to all this. So basically, and I gave a talk recently at GitHub Universe about this. And so now that that's available, now Hugging Face teaching it is way easier because yeah, if you're fine tuning a model with a CPU, it's just awful.
Yeah.
Like, I mean, just but now you can do it. And in fact, one of the things I'm trying to do with students is have them all actually upload their own models to Hugging Face and upload their own data sets just so they get familiarity with this. And so your model actually, I would be very curious to try it out. Is it already on Hugging Face?
No, I mean, not on Hugging Face, but I can provide the code. So this will be part of like a conference proceeding. So I'll definitely publish the code, and I'll be happy to send it to you. Yeah, I mean, typically like the models that are published in Hugging Face will have some sort of like pre-training objective. Like if you change the entire training paradigm, then probably it makes sense to upload to Hugging Face. Mine is just like fine tuning on a particular data set. But uh, but it's good to know that like you have dedicated GPUs. Like when I mean the other option is to like have a shared cluster with like several GPUs, and people could be requesting it on a first come first serve basis. But that's how
Yeah,
we had for several classes that I took. But it's good to know that people are getting dedicated
yeah,
GPUs.
it's very new. It just happened. And in fact, the other thing is that the machines, which again, you're part of Duke, so I can give you access to this. Is that the memory is extremely high as well. So they're like 120 gigabytes of RAM. So in very large disk. So for training exactly the kind of problem they're working on, it's ideal. And then the other part why again I think it would be interesting to see, have you tried this MLOps template that I created, is that it has pre-installed Whisper as well. And so what I think is interesting about Whisper is that it does solve some of the problems of getting the data for fine tuning,
Mhm.
because all you need to do is just record some content and just and then tell Whisper to transcribe it to text. So whatever the data set it is you want to create, you just create it yourself, right? You just talk, right? So you just say whatever it is you want to show up into a text file,
Mhm.
and then Whisper will use its own LLM, and it's extremely accurate to then take that and then transcribe it into a text file, which then you could feed into Hugging Face. So that's why I think that some of the MLOps techniques of being able to have automation around things are really conducive to like traditional research.
Wow, yeah, that's a interesting way to create a data set. Like you no longer need to type text to create data set, but rather just speak or like record yourself and then wow.
Yeah, or even grab other people's recordings.
Hmm.
Right, you could go to like anybody that gave a conference talk
Yeah,
or whatever. You could download their talk and
yeah,
then just use Whisper and then take that into the training set. And then you're right, you always obviously could augment your own.
yeah. Even I also recently heard, I think Microsoft's cognitive services providing transcripts to Zoom so that it's becoming more accurate. So thing is like, yeah, once you have a very accurate model, you can outsource it, provide it as a service to other uh, services as well, like Zoom and Cisco has one, I think, a video call service. So yeah.
Yeah, what where I see some of the stuff happening that's pretty interesting is that what we're going to see is that the large language models, a lot of the pre-trained models, are they themselves going to empower the creation of data sets and models and techniques so that you can then create new data sets, models, and techniques? So it's like a recursive, like, and a great example is the Whisper, right? Like it's an LLM, and then you use that to create more data, which then makes models better, right?
Yeah,
So
yeah,
it's right, it's a feeding back into itself.
yeah, yeah. That's also there. Like we in ML, like the feedback based loop. Often we evaluate model based just based on its accuracy, but if we can use the accuracy as a component to further increase the model's capability in the next stage of training, then we are going to get even better accuracy. So that's pretty good.
And then the other one that's related, that's a big deal right now, is the AI pair programming. Have you had a chance to play with either Copilot or Code Whisper yet?
Yeah, Code Pilot. You mean the GitHub Copilot, right?
Yeah, yeah.
Yeah. Definitely. Yeah, that's pretty interesting. Like it just takes out. I'm not sure like if it takes out exact code copies from the internet or like if it generate. Yeah, it's a mix of both. I'm guessing, but yeah, it's pretty accurate. Like for the functions that are used in a standard basis, it's pretty useful. Like the for loop and all that in Python.
Yeah, and for boilerplate code, like what I've noticed is, and I'm also teaching that as well, is I'm teaching students, I'm recommending that they use Copilot when they code so that they can focus on the logic, and then the boilerplate code just gets written automatically. And so that's yet a second kind of a tool that, even though you're trying to create machine learning systems or machine learning models, you have the AI tool like Copilot is one, you have Whisper is a second. So you have these tools that then they themselves were built with AI, then helping you create AI,
Hmm.
which is very interesting.
Yeah. I mean, yeah, that's going to be. I mean, as the efficiency of these large models are going to keep increasing. Yeah, I don't know. Like the data sets that they're going to be annotating are going to become even better. Yeah, like right now we still need human intervention. Like most data sets are created by humans and experts. Like for instance, like you have a history data set, you probably need historians or someone working in that field to mark. But as the AI takes over, we have to see how well it's going to get in terms of labeling them.
Yeah, this is very very interesting stuff. And so what else are you working on that people might want to pay attention to?
Yeah, so I can share my like my Google Scholar or like my web page where I've worked on my recent research contributions. Yeah, so pretty much I've been working on, as I said, on structure and feedback based. One thing is how can I bring in classical syntactic structure that's present in languages onto deep learning models. That was my first contribution. The second one was numerical structures, which I
Mhm.
presented. So there were two contributions on numerical structure. The first one is more about question answering, summarization and all that, which I presented last year. And this is more towards number entities. We have something called named entities in NLP. It's called named entity recognition, or NER. And I'm proposing that we also should have number entities, since numbers are often overlooked in the NLP
Mhm.
literature. And apart from that, I've also worked on like feedback based models that you mentioned, uh, where I tried to improve the performance across multiple languages. Like you have a language inference task, for instance, like whether to see two sentences are related to each other. The performance is very high, typically on English and other high resource languages like French. I tried to like use the knowledge from these high resource languages and transfer them to low resource ones, like a few languages from Asia and Africa, and improved performance on them. Uh, that was the other topic that I worked on. But other than that, I'm also working on summarization and yeah, more tasks.
So with summarization, maybe I could ask you a few questions, and since you know a lot more than I do, one of the things that I've noticed is that with Hugging Face, at least the models that I've used, it seems like there maybe are two styles. One is that you summarize an entire document to just a single sentence, so you have almost like it's generating a
Yeah,
title, and then you have others that are more of like a paragraph or two. Are would that be a fair way to
yeah.
represent
So
it?
it's called like the two types are called abstractive and extractive summarization.
Oh,
So
okay.
whenever you want a condensed representation of a paragraph, it's called like abstractive. You write abstract about an entire article.
Okay.
Very much possible. And extractive is you give the abstract and the entire article is generated. That's the ideal scenario. But of course, I don't think the models are pretty good to like write a whole article with an abstract. I mean, it should be pretty readable, but for a science literature, I think it'll still need like some more efforts. But for condensing a paragraph to few sentences, the models are pretty efficient, since a lot more information is present in a paragraph than a couple of sentences.
I see. So that's really that's good to know. I didn't know that. Like that, basically, where we're at is that summarizing like a page to a few sentences is pretty good, but the entire book or a chapter or something, trying to summarize that is still a little. It may not be as good a results as you would expect.
Yeah, yeah, especially since you are increasing the vocabulary. Like you just give two sentences as inputs, and you expect the model to like write pages and pages of document. Then yeah, the context might go out of hand. Like
Mm.
uh, it's tough to like find relevant terms in vocabulary and write coherent paragraphs, since the intention of the reader is not specified, usually not specified in a couple of sentences.
And if in terms of the 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 models that you would recommend people use, are there any particular ones on Hugging Face that you would recommend?
So I've used yeah, in terms of like resources, as well as like the ability to easily fine tune for someone who's just starting, I would say uh, yeah, BERT and T5. Like the T5 models is like a sequence to sequence model, which means that you feed in an input sequence, it generates output sequence, and it's just a standard encoder decoder framework that anyone can start learning. So I would recommend, like, there are three versions of it as well. I think T5 small, large, and like even a bigger one model. And the T5 small is like kind of easy to fine tune, as it requires not that many parameters compared to the T5 large. So that would be a good starting point for summarization.
Okay, and T-Fi small, if you do have access to GPU, should be pretty fast then.
Yeah, yeah. If you, especially if you have that 125 gigs of RAM, that kind of GPU, yeah, definitely it should be pretty fast. Like usually we have this problem of batch size when you're fine tuning NLP models. So the RAM dictates how many samples I can hold in a batch,
Mm,
because when fine tuning, you're not going to feed the entire corpus, at a time. You're going to feed like batches of sentences at a time. So which means that RAM actually holds all those things in memory, the model as well as the data. So since you have a very having a higher lot of RAM in terms of GPU memory is going to be helpful to increase the batch size. If you increase the batch size, then the amount of time it's going to take to fine tune becomes less.
And would you say, like, in terms of the T5 small, what are the domains that's you would recommend someone fine tune it for? So, and what would they use as a data set? So let's maybe take technical content, like, because that's something I do a lot. If I wanted to summarize, technical content and fine tune it, where would you recommend I start? Like, what would be the process?
So usually, like the pre-trained versions of a model like T5 would not be very domain specific. It would be like more like open domain, as in the kind of tokens that's used is not tied to a medical or like history or legal domain. So what needs to be done then is like you need fine tuning. So that's why this act of process of fine tuning is very helpful. So if I'm gonna process legal articles, I need a corpus of legal articles and then use them to fine tune. In that way, we hope that the model is gonna adapt to articles from legal text. But there are also versions of models these days where the pre-training objective itself is done on a domain specific data set. For instance, in bird we have like legal bird, medical bird and all that, where the pre-trained itself was done on a specific domain. And what happens is these models will be more relevant to that particular domain, and it will have tokens or like words that are often found in that domain. So if I would do like a classification on COVID data set, probably I would use a medical bird since it will have much more relevance to those terms.
And then you would fine tune from there, or that's
Yeah,
maybe it's good. Oh, you would. Okay.
you also have to fine tuning is anyway needed to have more context, because like the pre-training embedding representations are not going to have very high relevance to what we are doing, since the task is going to be different. Like you cannot just have a pre-trained model and directly do question answering, summarization and all that without giving it objective. That's why we need fine tuning. But it also could be very useful to have a relevant pre-trained model that's targeted to that particular domain.
So it seems like, well, I mean, and this is why it's such a complex topic to teach, is that one of the problems is, first you need to have the hardware, right? Like, if you don't have the hardware, you just can't do anything. So that fortunately with GitHub now they've solved that. But then the next thing that's a problem is, okay, so you have the hardware, and let's say you even have the medical BERT, but then now where do you get the data set?
Mhm.
Right, like, so that's the other, no, I guess, and that's where Hugging Face, in theory, it could really play a role, is that you could, as more people put
Yeah.
curated data sets into Hugging Face, then you just pull down that data set, and then you fine tune on that.
Yeah, that would be more useful for someone just starting with Hugging Face, because they don't need to write custom code to like pre-process the data set and all that, since Hugging Face would have done most of it. Like they
Mhm.
would have separated partitions for train, test and valid, and also like other pre-processing things like removing punctuations and all that. But if you're going to have your own data set, it needs to have a separate pre-processing function, and then even the format at which it's fed into the Hugging Face model, because you cannot just feed in raw text. So for any NLP models, it needs to be converted to tokens, and that's done using something called tokenizer. So tokenizer basically converts words to numbers, since you cannot do training on actual characters and words. It needs to be a number. So it assigns kind of like a unique identifier to each token, and complex words are broken down into like subwords or like small tokens, and that is carried on by the tokenizer. And each model has its own tokenizer. Like T5 has its own tokenizer, BERT has its own tokenizer. So that's the first step that is done after pre-processing.
So basically, to make it even more complex, is, so A, you need to have hardware. B, you need to have, in the case of if you really were going to create your own fine tuning from scratch, you would need to pre-process the data. Then you would need to not only pre-process the data and clean it up, but then you would also have to create your own tokenizer, right?
Yeah, the tokenizers come with the model. Like we don't need to create a tokenizer ourselves, but though there is an ability to do that as well. Like for more, if you're going to write your own tokenizer with a certain objective, that's also possible, but it's not required in most cases.
I see. So,
So
it's only if, and with the tokenizer, you would like in the example that you were showing, for example, how many tokens would typically exist?
So in the T5 small model, there are around 32,000 tokens,
Okay.
uh, and those tokens don't represent words. By the way, like since that doesn't mean that there are 32,000 unique words. It just means 32,000 tokens. So the token could be a word or a subword. So subword is like, let's say you have a word like computer. The word could be broken down to com, and then puter could be another subword. It's just that, like, the model does that to find common prefixes and suffixes
Mm,
across words, so that it doesn't need to like think of each word as a unique word. Like you're going to have a lot of words in English with common suffixes. Like for instance, tion is a common suffix, like completion. uh, you
oh,
have
I
this
see.
tion. So basically the tion would be broken down to a separate subword, so that whenever you find another word with the same suffix, the model is going to know that these two words share that suffix in common.
And
So
would you say, like, in terms of some of the LLMs, what would be a number of tokens that someone would expect?
yeah, so I think like it should be around that 30 to 50,000 range is what
Okay.
I think. Yeah, you don't need more than that, since you're also going to break down words to find common syllables and suffixes. You don't need like typically more than that. But if you're going to represent all the words as the way it is, then I think, like, I don't know how many words are there in English language. I think it's around like 100,000 plus range.
Okay.
Yeah, so you
So,
would need that much to represent the entire
so
language.
then why do they say that, for example, with LLMs, some of them, they're like, billions of parameters. Like, what do they really mean by that? What are they referring to? Is it they're not just referring to tokens, then they're referring to.
No, yeah, those are like weights. So tokens are like just number of unique uh, representations that you have for the entire vocabulary.
Mhm.
But those parameters that they call are actually weights. Like
Mhm.
since in a transformer you have like 14 layers, and each layer would have, let's say you have 14 layers, and each layer you have like several operations. There is like a lot of things that I can talk about, like for instance self attention, cross attention, and like fully connected network. So these are all different operations for which you need weights and biases that involves a lot of matrix multiplications. So they count like each weight as a single parameter, and if you add that up, then you reach that many billions of parameters.
So how would someone even be able to reason about creating billions of parameters? That seems like so a lot of this stuff is automatically being created in code, right?
Yeah. So it's a very extensible way of creating. This is like, since we have this object-oriented way of creation, you just write a single layer and then call it n number of times, and
Mm.
it then accumulates and becomes exponential. Since each layer depends on the previous layer and so on, it's going to be like a chain of matrix multiplications, and that's how we get these many parameters.
I
Yeah, we don't really have to hard code or like explicitly state that we have to create a model with billions of parameters. It just happens to be billions of parameters.
And are tokens an input into the billions of parameters? Like, the more tokens, the larger the parameters?
Yeah, that's in general that's that's the rule, but I would say, like, even with less number of tokens, if you want like very efficient representations for those tokens, you need like lots of parameters.
Mm.
Like in deep learning they say like the more depth that you have for a model, the more accurate the representations are. Like that's been shown to be true. So yeah, but what you said is generally true. Like if you have more tokens, it's better to have more parameters.
Got it. And so there could be like a trade-off then with if you wanted to build something that wasn't technical, it was just maybe common English, then you might actually have really good accuracy by keeping the maybe less tokens. Like
Yeah,
if you have less tokens, you could specialize like a very simple, like maybe just very common phrases,
yeah,
because then you wouldn't need as many parameters, and maybe you
yeah.
could train it for a lot longer.
Yeah, another advantage of having less tokens is like at the end we are going to do some operation like either classification or generation. So it's always like choosing one out of many, right? So whenever you have to choose one out of many to do a classification or generation, like the more the options that you have, more complex it becomes for the model to choose one. So in general, it's good to have less number of tokens so that like the number of choices in the denominator is not too high.
So,
And for instance, in generation, you have something called beam search, where like you're going to find a chain of tokens that forms a sentence. And the more the options, it's like the number of combinations becomes exponential to form a sentence. So
and so would that mean also that inference would if you have smaller tokens, then inference maybe could be very fast?
yeah, definitely. Yeah, the beam search, like for instance, is an algorithm used for text generation. And in that, like, for every token, let's say I can choose in the search space, I have 1,000 tokens.
Mhm.
So I can pick like the top five. If that's the condition I'm giving the beam search, that let's say the first token in my sentence is an article, then the could be followed by any word pretty much, right? Like, so let's say I pick only top five words, and the next word after the second word, let's say like an animal or something, and then the number of options are going to become even more higher now. Like if I had not chosen an animal for the second token, and now if I come to third token, there are even more options. So that is dictated by an algorithm called beam search. And there it has been shown that having less number of tokens in the search space would make the algorithm more efficient. And alternatively, what you can do is not let the model choose from all the tokens every time. You can just have a beam search with a width of 2, so that every time the model only searches for 2 tokens, not like more than 2.
Ah, so so
And that's
so
like a trade-off.
yeah, so that's interesting because like what I guess what that means is that, like, I guess, intuitively, which might be wrong, someone who's going to fine tune something with Hugging Face, they may wrongly think like more tokens, right? And so they're getting more and more like, technical content,
Yeah,
on one hand, it's sure maybe it gets a little bit more accurate, but the flip side is that it could take much longer to train, and then when you do inference, it could just be very slow, right?
yeah. Especially for text generation, like if you which is used in machine translation, like that is like very I've seen that inference is very slow for high resource languages, like like I'm doing English to German translation, then the number of tokens in both the languages happen to be high. And it also depends, like the good thing is like the continuous improvement of GPUs. So we probably might not even notice this, as we are going to have better GPUs like with like 200 gigs or 125 gigs of RAM. But when I used it in my first few years of grad school, I noticed a significant delay in like text generation because of this reason. Sure.
Wow, I mean, and these are interesting problems from an MLOps perspective, because if a company is maybe starting to use Hugging Face and they're really excited, they're doing all this stuff, that one thing that they should maybe be careful of is that if they do too much fine tuning and they add too many tokens, then they may need extremely good GPUs,
Yeah.
right? And maybe they can't afford it. So maybe there's a trade-off between like doing just enough fine tuning
Yeah.
to make it better versus if you do too much, it could cost too much money to run the model in production.
Yep. Yep.
Wow, I didn't know that. That's good to know.
Yeah.
Um, yeah, well. Thanks for we spent about an hour. I learned a lot of stuff about NLP, and I'm sure we'll talk again soon.
Yeah. Yeah. I mean, and thanks for to you as well, like for supporting me uh, throughout, like not just in the TA, but like for inviting me to like share my thoughts about my research.
Yeah, I think this will be great to. Do you have maybe 5 more minutes?
Yeah. Yeah.
Yeah, I think so. Someone asked a question. There's two questions here. One question is, what data augmentation tool do you use for balancing?
So here, like I'm not shown the data augmentation process, but I did not use any specific tool. Like, so the idea is I created numbers. So since you know, for numbers you don't need to like have a particular strategy. So what I did was I used something called like contrastive learning to create more numbers. So whenever I find a data point for the category year with a value, let's say 1923, all I need to do is like swap that number with another year. So then it becomes a new data point. And it still stays relevant. Like let's say this war happened in 1923. I can also say that the same war happened in 1946, and no one is gonna say anything about it. So that's the strategy I used for creating more data points in this case.
Got it. And another question someone had was, can you talk about chatbot cases and also reformer models? So maybe start with chatbot.
Yeah. So for chatbot, it comes under like we call in NLP, it's called like dialogues. So I mean, I've not worked specifically on that, but I mean, which component do you want me to talk about it? Like the how it's implemented, or like the
So
use cases
this
of
is well, this is just a question from somebody asking from LinkedIn.
okay,
I'm assuming they just want to know about like, you know, maybe hello world,
yeah,
how is chatbot different than summarization, and
okay,
how can someone, if they want to build their own chatbot
yeah,
with Hugging Face, for example, what would they do?
yeah. So yeah, so chatbots are different in a sense that they are state based, as in like initially it starts with the lowest complexity. Like the first utterance that I give to a model, I can say anything. But following that, then my next utterance is based on the reply that I'm going to get from the model. And then the reply in turn 3 is going to be based on all my previous replies, all the previous replies from the model, and all the utterances I made to the model. So it's going to get like exponentially complex as we're going to go. It's more like a tree based structure. So that's taken care using state based dialogues in the NLP literature. And regarding like using a chatbot, I think Hugging Face has deployed like uh, the state of the art chatbot right now. And I remember using it, like you can just go and literally have a chat with it. Like,
Really?
yeah,
Wow.
yeah. Both Hugging Face have done that, and also all these companies have done that. I'm not sure if they have it live right now. Uh, like I mean, you have all these voice assistants, of course, on your phone, like from Google, Apple, and all that. But in terms of NLP literature, I think Hugging Face has deployed a chatbot that you can try, and it's pretty good for having uh, open domain dialogues, I would say. But the last time I tried, it was not very accurate on like a particular closed domain. Yep.
Mm, okay. And then the second question is reformer models. I don't even know what that is.
Okay, so yeah, I've also not worked on Reformer, but I think it's like there are different versions of Transformer, and we have long former, for instance, like Transformer original model didn't work very well, or it was not designed to handle long sequences, so they kind of extended it to make it work on sequences with very high length.
Ah,
Typically, we have like 512 tokens in the sentence, and even more than that uh, for for feeding in like paragraphs and paragraphs, or even pages and pages of text. And I think there's another version is probably called Reformer, and I have to look closely into it. I'm not worked with it.
got it. Yeah, I mean, it seems like then maybe like a takeaway is that it seems like if you're interested in machine learning at all, Hugging Face is probably the top tool to use, right? I mean, at this point, like, every 6 months things change, like, but it seems like if you're not using Hugging Face, you don't know what's going on.
Yeah, especially for language models, I would say. Like rather than saying general machine learning, yeah, for NLP, I think Hugging Face is a very good tool to start. And
Great.
if you're not going to write your own functions and just want to use a model that's been done by someone else, Hugging Face is a good place to start.
Yeah, and maybe like a related question then would be that yeah, I forgot to ask you this was, based on now what I know about from you from about the fine tuning process, wouldn't it be true that the cloud companies that provide pre-trained models, so like AWS has Comprehend, or Google has language models, that they're not always that great because they're not fine-tuned, or do they have a different architecture that makes them generalizable?
Yeah, so again, I think even models developed by Google, like Google, Microsoft, Amazon, they also take part in the research. Like, so
Mhm.
basically, it's either like researchers working with these companies, they come up with those models and it's published as a peer-reviewed paper. So I would say like the process is pretty much the same for any other company. Like you just have to go through that research process and then deploy it. So in that case, it has to go have the standard template of pre-training and fine-tuning. So I would not assume that any model that's there on the internet is just like drag and drop where you can do it on any tasks. I would still expect it to be fine-tuned on a particular data set to work for it to work well.
Yeah, so it might be then like that, like if I was going to use AWS has a service called Comprehend, that that may be, I'm just thinking out loud, but that might be why they haven't released some features, because all like Comprehend does entity extraction, sentiment analysis, things like that, but it doesn't do some of the things like summarization, or it doesn't do uh, generation, right? And I'm wondering if part of that is because it's a generic API, it may be very difficult to do a generic summarization. Would that be correct?
Yeah, yeah. It would still be difficult to do all the tasks at once without any fine tuning. So that
Okay.
that so I would still think that any model has like a relevant task that it works very well, and some other task that it doesn't do as well.
Hmm. Yeah, that's definitely interesting. Food for thought. Well, I think we got all the questions here, and if people want to get a hold of you, they can. What's a good way for them to talk to you? Since I'm going to put this on O'Reilly, I'm sure people will
Yeah,
get in
I
touch with
can
you.
send my email to you, like my personal email. Yeah, that will be a good way to reach
Okay,
out to. Yeah,
great. Well, thank you so much for your time, and yeah, we'll talk again soon.
yeah. It was pretty great, and thanks again for giving me this opportunity.
Okay.